Ladies and gentlemen, let me present you this vintage American beauty Drake Lima 7. 29, 29, 29. 29, 29, 29. Drake is running at 2 kilowatt output after making all the modern modifications, optocoupler, relay PTT, U-shape parasitic suppressor, bias 9 diodes, 1 November 5408. We keep it simple here. Of course, you can use the W4ZT bias board adjustable bias, or a very simple circuit of William Moore's W6 Sierra Alpha India at page 1227. It has a very nice bias circuit with only one NPN transistor. You can use a tip 35 power transistor, and to select the diode you like. We have tested this circuit and this circuit, and they both they work fine. Of course, we have grounded the grids. Bear in mind that at bias you haven't to stop at the bias voltage. You have to check the bias current. Bias current is the thing you want to see. Every company, Ameritron, AMAC, I'm sorry, at the datasheet it says for each tube 3500Z it needs 130 milliamperes per tube to be at the AB class, AB2 class. So for two tubes you need 260 milliamps dead key to stay at AB2 class. Of course you can lower the bias current to 100 milliamps, but there problems are starting, because at the first key or at your first word at the microphone it will be distorted. So stay at the safe side of the story and stay at the upper limit of cutoff bias. Of course we have grounded the grids, we have changed the mica tank capacitors underneath the tank with that fat boys here rated at 30 kilovolts. The mica capacitors from the factory was at 2.5 kilovolt, but this Drake is running at 3.7 kilovolt DC. Of course we have soft start, Russian military vacuum relays, tube anode heat sinks, and the power supply is 3.6 kilovolts with that bad boy here. The original factory transformer, it was this one. This transformer is the same with Kenwood TL922. It produced 900 volts AC. After doubling it's going to 1.8 kilovolt. After rectification it goes to 2.6 kilovolt. Key down is the 2.2 kilovolt. So 2.2 kilovolts with 600 milliamps at the plates. Do the maths. The power output is close to 1400 watts, 1500 watts, no more. With this bad boy here it's 3.6 kilovolts with 3 taps in the primary, the 230, 220, 210, and it can produce 3.7 kilovolts, 3.6. We work it at 3.6 kilovolts. Key down is the 3.3 kilovolts. So do the maths. 3.3 kilovolts times 700 milliamps at the plates. Do the maths and see that you will have a PPSSB 2 kilowatts at the output. 2 kilowatts 24/7. Of course we have 5 blowers now. It's the one of the factory here, at the back. We have two at the filaments here, 8 centimeters diameter, and another two at the cover. Now, for video purposes, you see the amplifier without the cover, but at a normal working condition, there are two 12 centimeter diameter more. So 29, 29, 29, 29, 29, 29, 10, 10, it's glowing red. One friend of mine told me, that tube is glowing. That tube is glowing. You shorten the tube's life. Remember, when tube is glowing, you create vacuum. Vacuum is something that tubes, they like it very much. And when you have 3.6 kilowatt at anode, you lower the grid current. This is the tip. When you work with grounded grid triodes. These two tubes, the one is AMAC, the other is the ZG, the Chinese. Bear in mind that these tubes are more than 10 years old. You can see glowing the AMAC because it has a plate of simple metal. You cannot see easily the ZG with a heavy cement anode to start glowing. The Chinese ZG starts glowing only at FT8. When I bought this amplifier used from one ham radio operator. He had bought it from another ham radio operator. This AMAC, it's starting glowing blue light. It had lost the vacuum. After leaving it 1 week with the filaments and no high voltage, after 1 week I started with 100 watts, the second week 500 watts, the third week 1 kilowatt, and slowly I create a vacuum inside with the high voltage, and now is running both tubes at 2 kilowatts. Remember that they are more than 10 years old. You will not shorten the life of the tubes if you higher the plate voltage. So that's why these amplifiers, they are working half a century now. It's made at 70s era. It's working until today, and it will serve very easily the next generation after we will be silent keys. Do me a favor, go to Pentalab sites. At the very end, at the very bottom of Pentalab, there is a video of Mr. BBI. Mr. BBI is one of the 3 major maintenance guys, and he makes amplifiers. He made a test. Check this video. This video is a pair of 3500Z producing 3.5 kilowatts at the output with 240 watts in the input. Of course, Mr. BBI says that it's only for testing purposes, not for everyday use. This amplifier is for everyday use. You can run it 2 kilowatts every day, 24/7, especially in the contests. Different operators, no problem at all. And that's why tubes exist right now, because tubes can resist more than 3-to-1 SWR and more than 250 millisecond CW spikes. This is the things that LDMOS amplifiers cannot do. Of course, LDMOS amplifiers, they have improved the last decade, but they need another 1 decade. Maybe they will reach the tube amps. One friend of mine told me, I'm an electronic engineer and I can tell you for sure that LDMOS amplifiers, They can resist 65 to 1 SWR, especially the XR series. Mr. John, take your 65 to 1. At every international contest, the contesters are with soldering irons, repairing finals at LDMOS amplifiers in a row, one by one. First, CW amplifier, second, SSB amplifier, after FT8 amplifier, and I don't talk about T80K that people send photos. I mean at every contest.